All right, here's a few questions on um, rationalized denominators and, in addition, solving a radical equation. Okay, to solve or to rationalize a denominator, you need to take each term and you're going to multiply it by something so that I can get rid of this or get rid of the radicals on the denominator. If there's two terms like this question, so here's a term, here's a term, I'm going to multiply both top and bottom by the conjugate of this, which means I'm going to multiply by root 3 plus 4 root 5. And if I do that on the bottom, I have to do the exact same thing on the top. So I can't change signs. These two signs have to be the same, but they have to be the opposite to whatever that one is. Okay, so now it's a game of FOIL. So you get to FOIL all of this stuff out. So let's multiply the top. Root 5 times root 3, root 15. Root 5 times 4 root 5 would be a plus 4 root 25. Minus 2 root 6 times root 3 would be a minus 2 root 18. Ooh. And then minus 2 times 4 root 5 will be a minus 8 root 30. Okay, that's good for the top. Now on the bottom, root 3 times root 3 is root 9. Root 3 times 4 root 5 would be a plus 4 root 15. And then this times this would be a minus 4 root 15. And then this times this would be a minus 16 root 25. Okay, now let's see some simplifying if we can. These two will cancel out, so they're gone. And then the square root of 9, let's just do the bottom. The square root of 9 is 3. Square root of 25 would be 5, so this would be like minus 16 times 5, which, let's keep going on the bottom. That'll be 3, take away 16 times 5 is 80. So on the bottom, I'm going to get negative 77. Okay, now let's do the top. Root 15, I can't do anything with that. Plus, now root 25 is 5, so 5 times 4 would be plus 20. Minus 2, 18. Well, 18 is 9 times 2, right? And the square root of 9 is 3. So this would be like minus 2 times 3 times root 2. Sorry you can't see that well, but that'll be minus 6 root 2. And then 30, I don't think one of those pretty numbers will go into that. So I think I just leave it as minus 8 root 30. None of these are like terms, so that's what I would write in the end. Root 15 plus 20 minus 6 root 2 minus 8 root 30. Let's do another one, just because I'm having so much fun doing these. Okay, next one. I've got 2 minus root 9 all over root 3 minus root 7. So I'm going to multiply top and bottom by the conjugate of the bottom. So the conjugate is the same thing on the outside. I just have to change that sign from a minus to a plus. If I do that on the bottom, I do the identical thing on the top. And then it's a game of FOIL. Okay, so 2 times root 3 is 2 root 3. Oops, 2 root 3. 2 times root 7 is plus 2 root 7. Minus root 9 times root 3 would be a minus root 27. And minus root 9 times that'll be a minus root 63. And I don't think you can simplify any of that stuff. And then on the bottom, root 3 times root 3 is root 9. Root 3 times this would be a plus root 21. This times this would be a minus root 21. And this times this would be a minus root 49. Now the top can't do anything with, so I'm leaving it. Minus root 27 minus root 63. It'd be nice to be able to combine stuff, but none of them have the same radical, so you can't. So it's that over root 9 would be 3. Root 21 minus these cancel, and then minus 49 root 49 is 7, so it'd be minus 7. So on the bottom I've got 3 take away 7, which is minus 4, and then on the top I have that same stuff that you can't simplify. I don't think you can. I can't see any way to do it. Okay, so that is rationalizing the denominator. Now here's an equation that we need to solve. And when we solve any equation, I'm wanting to solve for x, so in the end I got to have x equals something. But when I have a radical involved, I first want to isolate that radical. So I have to get the 7 moved to the other side. So I'm going to have 2 root x plus 1 is equal to x minus 7. Now that I have a radical isolated, I could at this point divide by this 2 to get the radical totally isolated. But if I do that on the right side, I'm going to get fractions. And so I think I'll just leave the 2 where it's at. So I'm going to take and I'm going to square this side and square this side. When you square this, when you have a 2 out front, you've got to square the 2 and this radical term. So when you square the 2, you get a 4. And when you square the radical, those cancel out, leaving you with just x plus 1 is equal to, and then on this side, I've got x minus 7 times x minus 7. Careful that you don't just take that and go x squared minus 49 or plus 49 or something. That's incorrect. You have to FOIL that whole thing, which we'll do now. X times x, x squared, x times minus 7, minus 7x, another minus 7x, plus 49 is equal to, and I can distribute the 4 here as well, 4x plus 4. And then since it's a quadratic, I'll bring everything over to the right side. So I'll get x squared, this will be minus 14x. Then if I bring this over, it'll become a minus 4x. I have a plus 49 already there. If I bring this over, it'll be a minus 4. So I'll have 0 is equal to x squared minus 18x plus 45. Is that right? I think so. So it's a quadratic. Now I can use all my quadratic tools to help solve that. I could graph it and find the x-intercepts. I could use a quadratic formula, or I'm praying that a bit of factoring will work. Now 45, that's 9 times 5. When you add those, yeah, it's not 18. What else? 15. 15 times 3, that's 45. When you add them, you get 18. Yeah, those are the ones right there. But they have to add to a negative 18, so both of these would be negative. So it'll be x minus 18 and x minus 3 equals 0. So either x minus 18 is 0 or x minus 3 is 0. So x is 18 or x is positive 3. Now when you plug those numbers into the original equation, you've got to make sure that they both work. So, why am I saying 18? Where did I get that 18? Oh, I got the 18 from there. I'm supposed to be using minus 15. That's a 15, a 15, and a 15. There we go. Okay, so if I plug them into the original equation, 2 square root 15 plus 1 plus 7 equals 15. Let's see if it works. 15 plus 1 is 16, plus 7. Square root of 16 is 4, so 2 times 4, which is 8. And 8 plus 7, yeah, that's 15. Yeah, that one works. And then you could do the same thing with the 3, plug the 3 in and see if that works. Okay, so there's one equation. Let's see if we can do another one. Similar kind of question, but this time the radical is already isolated. So to get started, I can just square this side and square this side. So on the left side, I'll have x minus 3 times x minus 3. On the right side, I'm just going to have 27 minus 3x. And then on the left side, I can FOIL that out. The x squared minus 3x minus another 3x plus 9 equals 27 minus 3x. Since it's a quadratic, I'll bring everything to the left side. So x squared minus 6x. If I bring this over, I have to add 3x. I have a plus 9 already. If I bring this over, it'd be a minus 27 equals 0, because I want it equal to 0, right? So x squared minus 3x, what's this going to be, minus 18? I think that's right, is equal to 0. Then either quadratic formula or see if you can factor. And I think this one is minus 6 and a plus 3. So either x minus 6 is 0 or x plus 3 is 0. X equals 6 then, or x is equal to minus 3. Again, you'd want to plug these in to make sure they work. Let me try and plug this one in and see if that works. So it'll be minus 3 is equal to root 27 minus 3 times minus 3. So minus 3 is a minus 6. Inside the square root, I've got 27. Minus 3 times minus 3 is plus 9. So I have minus 6 is equal to the square root of 27 plus 9, that's 36. Oh, and the square root of 36 is 6. Oh, but it doesn't equal minus 6 because it has to be a minus 6. Those don't work, therefore this one doesn't work. That one I'm assuming to be your only answer, but I would plug the 6 in just to make sure that it works. All right, hopefully that helps you with those questions.